Welcome students to my channel GS Maths. Today's topic is surface areas and volume of the solids from class 10th. Now to begin with, let us first know the basic formulas, how to calculate the surface areas, how to calculate the volumes of the solids. It will be a combination of solids in this chapter. Say a cone is surmounted on a hemisphere, or say a cylinder is surmounted on a hemisphere, and so on. Now, first of all, let me discuss the formulas. To begin with, let me begin with the cube. Now, as all of you know, all the faces of the cube are square shaped, like this. Say this is x, the height is x. So the volume of the cube, is h cube, that is x cube. This is the first solid I will discuss, the cube. Now, surface area of cube, that is h square into 6, that is 6 into h square. Let this be 6 into x square, right? These are the two formulas of cube, volume of the cube and surface area of the cube. Second is cuboid. Cuboid is the faces are rectangular. Cuboid is where the faces are rectangular here, like this. Faces are rectangular. This is length, this is breadth, this is the height. The volume of the cuboid, this is a cuboid, the second solid, cuboid. Volume of cuboid, this is length, breadth into height. Then surface area of the cuboid. Surface area of cuboid, that is equal to 2 times length into breadth, breadth into height, length into height. These are the two formulas. Volume of cuboid, surface area of cuboid. One more area is there, that is called lateral surface area. Lateral surface area, that is 2 times length plus breadth multiplied by the height. This is called the lateral surface area of the cuboid. This is length into breadth, this is length into breadth, 2 times length plus breadth into the height. This we get as the lateral surface area. First I discussed the cube, then the second solid was cuboid. Now the third one is a sphere. It's a 3-dimensional circle, like a football. It's a sphere. Now it's like this. Third solid is a sphere. This is the radius. This is the radius of the sphere. The volume of the sphere is 4 by 3 pi r cube. Surface area of the sphere, that is 4 pi r square, and surface area of sphere is 4 pi r square. Now next comes the hemisphere. It's like this, just like a bowl, right? It's a hemisphere. Now volume of hemisphere, this is half of the volume of the sphere, that becomes 2 by 3 pi r cube, where r is the radius. This is volume of the hemisphere. Now surface area of hemisphere, now say it is 2 pi r square. If there is a lid on it, it's covered, I have to add pi r square to it also. Pi r square. It becomes 3 pi r square. This is surface area of the hemisphere. This pi r square I have added. If it is without the lid, without the covering, then it's 2 pi r square. If it is with the cover, I have to add pi r square into it. This is hemisphere I have done. This is the sphere. Now the next solid which will be considered in this chapter is cylinder. Is the cylinder. One more thing I left out. The diagonal of cuboid. Remember this also. It is length square, breadth square into height the square under the root. This is the diagonal of the cuboid. That is, length of the diagonal of the cuboid is found out by this, using this formula: length square plus breadth square plus height square under the root. Now, the fifth one is the cylinder. The cylinder. Cylinder is this. This is the cylinder. This is, say, radius r. This is height h. The volume of the cylinder. Volume of the cylinder is pi radius square into height. Curved surface area of the cylinder, this part, this part, the round part, that is 2 pi r into h, the circumference multiplied by the height. Multiplied by the height. If I have to take these two into consideration, then the total surface area is 2 pi r h plus 2 pi r square. 2 pi radius square. So what I can get, 2 pi r is common. 2 pi r is common. H plus r is left inside the bracket. This is the total surface area of the cylinder. This is the volume of the cylinder. Curved surface area is 2 pi r h. This was the fifth solid. Now the sixth one is a cone. The sixth one is a cone. This is called the slant height. This is the height of the cone. This is the radius of the cone. L is the slant height. L is the slant height. And if this is the angle theta, then theta is called the semi-vertical angle. Semi-vertical angle. Now how we can calculate the slant height? Just use Pythagoras theorem. It's a right circular cone. The angle is 90 degree. L square equals to h square plus r square, or L equals to h square plus r square under the root. This is the slant height. So volume of this cone, 1 by 3 pi radius square into h. Then curved surface area of the cone is pi r L. I can substitute the value of L as under root of h square plus r square. This is curved surface area of the cone. If I need to have the base also, then the total surface area of the cone is pi r L plus pi r square. Area of the base, pi r is common, L plus r. This is the total surface area of the cone. These are the 6 solids, or it can be a combination of these 6 solids. Any 2 of them, right, will be used. These formulas will be used in this chapter of surface areas and volumes of the solids. To begin with, I will do few questions, 1 or 2 questions, so that to understand the concept. Now, for example, combination of solids will be there. One solid surmounted by the another solid. formulas applied which I have discussed, right? Now say question is this: there is a hemisphere. There is a hemisphere like this, surmounted by a cylinder. Surmounted by a cylinder. Now the total height of this solid is 13 centimeter and the radius of this is 7 centimeter. If this is 7, this will also be 7 centimeter. The total height of the solid is 13 centimeter. Now from here I can make out that the height of the cylinder becomes 13 minus this 7, that is 6 centimeter. Now what I have to do is I have to find the inner surface area of the vessel. Now what is the inner surface area of the vessel? It's very simple. Surface area, I need inner surface area of vessel. This figure is given to us. So the upper part is the cylinder and the lower part is a hemisphere. It's a hemisphere. Now, inner surface area of the vessel. What is the surface area of this? It is 2 pi r square. This is of the hemisphere plus cylinder. Cylinder is 2 pi r h. Just fill the values. 2 pi is common, r is also common, r plus h. Now, radius is same, that's why I have taken this. 2 pi, radius is 7. 7 plus height of the cylinder, that is 6. Don't take the side. I am talking about this 2 pi r h. The height will be 6. That is 14 pi into 13. Just solve it by using, say, 14 multiplied by 13 into pi is 22 by 7. This cancels. 7 2. It is 26 into 22. This multiplication will give you, I think, is 572 centimeters square. Is the inner surface area of this vessel. It's a combination of a sphere and a cylinder. I was required to find the inner surface area of this kind of a solid, right? So I used the formula of the hemisphere. Hemisphere was 2 pi r square. I used the formula of the curved surface area of the cylinder, that was 2 pi r h. We substituted the values of the radius and the height of the cylinder, radius of the sphere, to get the required answer. Now, next is, he says 3 cubes each of 216 centimeter cube volume are joined end to end. Now cubes are joined, 3 cubes are joined end to end. Let me try to draw the figure. Like this. 3 cubes are joined from end to end, that is edge is joined. This thing. 3 cubes are joined. Now the volume of one cube is, this is 216, 216, 216. 3 cubes, each of volume 216 centimeter cube are joined end to end to form a cuboid. Now find the total surface area of the resulting cuboid. Okay. Now I have, say, volume of one cube. Volume of one cube. This is given to you as 216. This is x, this is x, this is also x. So volume of one cube, volume of cube is 216. This is x cube equals to 216. X equals to 6 centimeter. That means the edge is 6 centimeter. This is also 6 centimeter. Only thing changes is the length. 6, 6, 6. The length becomes 18 centimeter of the resulting cuboid. That is length of cuboid is 18 centimeter. Its height is 6 centimeter. It does not change. Breadth does not changes. Breadth is again 6 centimeter. So I need to find out the surface area of the resulting cuboid. It's very simple. Surface area of cuboid twice length into breadth, that is 18 into 6 plus 6 into 6, again 18 into 6. I get twice, it is 18 into 6, that becomes 252 when I calculate this. 252, 2 times 252, answer is centimeter square. This is the way how we solve these kind of sums. The three solids were joined edge to edge. Along the edge they were joined. One cube was there, 3 cubes were joined to form a cuboid. Only thing changes is the length. This is the length, this is the width, this is the height. The length of cuboid is this. I need to find the surface area of the resulting cuboid. Do like this. That is twice length into breadth plus breadth into height and L into H. Substitute the values to get the answer. Remember the formulas. Remember the formulas of cone, sphere, how to calculate their volume, how to calculate the surface areas to proceed in this chapter. Right? In my next lecture, I will again continue with the numerical problems based on this topic. Thank you very much. Keep on watching my video, and if you haven't subscribed my channel, please subscribe with GS Maths. Thank you very much.